It's my great privilege to welcome today's resource person, Dr. Dimple Nagpal, on the topic of applications of ML with IoT. Dr. Dimple Nagpal, currently working as Assistant Professor at Chitkara University. She pursued her Bachelor of Technology in Computer Science and Engineering from Kurukshetra University. Did her Master's in Computer Science from Chandigarh Engineering College, Lantern, and received Doctorate of Philosophy in Computer Science from Chitkara University. Her research includes ontology, component-based software engineering, and information retrieval. She has published many papers in international journals and conferences.
Madam Archanagar, you are muted and please unmute yourself and please.
Yes, sir. Already had unmuted.
Okay, sir. May I start now? Thanks.
Yes, madam. Dimple, madam, please proceed.
Okay.
Yes, yes.
சாப்பிட வரலையா?
Is my screen visible, sir?
Yes, madam. Your screen is visible, please.
Okay. Very good afternoon to all present here. So today I'm going to present on the topic applications of machine learning with IoT. Are the various applications involved in machine learning? What do you mean by the term IoT and how IoT amalgamated with machine learning? Applications of ML with IoT, challenges and future of machine learning with IoT. So the first and foremost thing is, what do you mean by term machine learning? Machine means computer, machine, and learning means you are learning the machine, you are learning the computer that okay, this particular thing is for classification, this is for regression. So we are learning the machine based on the some data, based on some, we are analyzing the data, right? So machine learning is a buzzword for today's technologies and it is growing very rapidly day by day. We are using machine learning in our day-to-day activities, even without knowing it, such as Google Maps, Google Assistant, Alexa. So machine learning is basically a technique that allows the computer to learn from the data without it being explicitly programmed. Computer is learning according to the features. Generally, the aim is to make predictions after learning, and the process operates by building a model from the given training data and then make predictions based on that model. That is known as machine learning. So machine learning is closely related with artificial intelligence because machine learning is also having various other applications, various other things that is there in pattern recognition, computational statistics, and a strong relationship with mathematical optimization. And we focus on the existing machine learning techniques that are suitable with the IoT in this particular presentation. And machine learning is one of the critical component of AI, where the algorithms are developed in order to improve the performance of the software. It uses big data to understand, it uses personalized experience to understand, and any e-commerce platform, streaming service, music streaming platforms used to users uses to understand it and provide with a better experience, that is known as machine learning. Next is, we talk about it's okay. Machine learning is learning from the previous experience, learning from the data, right? But why we are requiring learning from the data? Because there are large volume of data collected growing day by day. Since 2009 to 2022, it has data production has been increased to 44 times. And by this analysis of the data, by the implementation of the machine learning technique. Hello. Hello. May I continue?
Yes, ma'am. Please.
Okay. Okay. And because data is cheap and abundant, but if we produce it from data to knowledge and to that database where we are learning, we are implementing the computer, we are
It is
letting
a
it know to the
how
computer.
how human beings relationship. It is a study of how human beings interact with environment.
What you are saying, sir? Hello.
Ma'am, please proceed. Sound
Okay.
disturbance.
Okay. Okay.
We muted, ma'am.
Yes, sir. Okay. Next is, it's okay if we talk about machine learning, and machine learning is so much important. But first and foremost thing we talk about, we need to analyze the data. We need to predict the data. We need to classify the data. So there are various, approximately 7 steps how we will be going to perform the machine learning. First one is gathering of data. You can collect data. If you need to implement machine learning, if you need to learn the machine learning, there are so much public available data set available. But if you need to perform the societal benefits, you need to perform it, whether taking the data, if I talk about specifically in healthcare, so whether taking the data from hospitals, from EHRs, so you need to collect it from that. Now, if we gather the data as well, that does not see, that does not um, identifies that our data is correct. We need to prepare our data so that there are no ambiguities, there are there are no ambiguities in our data, there are no missing values in our data. So we need to prepare it so that computer can understand in a proper manner. It's okay, this data is there. Then we need to choose a model. Now choosing a model means we need to perform, there are various machine learning algorithms. We need to choose a model, which algorithm we need to choose. Now, how will we going to choose which algorithm we need to choose? We'll be learning in the later stage. Next is, we'll be training the data. It's okay that this data is for cats, or this data is for mobile phone, that this data is for computers. And based on that training, we'll be evaluating based on the testing data set. We'll be providing with one more image to the computer and check it whether the trained data or the trained model is evaluating correctly or not. And then we'll be having hyperparameter tuning and prediction at the later stage. So these are the these are the steps of machine learning. The first one. Now, if I talk about traditional programming and how it differs from machine learning. In traditional programming, everything, the data, handcrafted model is there. We need to feed to the computer and we need to extract the result.
जमा करायचंय
However,
मला हे पण लाईट होत्या मार्क लिहून घ्यायचे मला त्याच्यानंतर नंतर जेव्हा होते मला मार्क द्या सही लिहून
how,
नंतर मग करून घे. एक काम कर नाही तर मग
however, machine learning means you need to collect, you need to have the sample data, computer extract the features from that data, you need to only train the model, you need to only apply the model, computer will analyze that model, from that model you can predict which data is having which classification and so on. So that's the difference between traditional learning and machine learning. So how does ML work? We define that we need to define the objective, we need to collect the data, we need to prepare the data, we need to select the algorithm. We need to train, test the model and integrate the model so that applications can be used to the particular model. Now, if I talk about machine learning, so in machine learning, we are having 3 different types of model, because here we are saying we need to select the algorithm. But how can we select the model? How can we select the algorithm? So there are 3 different types of learning. That is supervised learning, unsupervised learning, and reinforcement learning. Supervised learning means, annotation means labels. These are the images of grapes. and we label them explicitly that these are grapes. It's similar to I am teaching you that these are the supervised learning. So I am explicitly teaching you with the proper information. So that is labeling the images with the model is known as, and we are predicting it, that is known as supervised. That is, there is one teacher that is telling us that these are the images of grape, these are the images of apple, banana, and so on. Next is unsupervised learning. Now, what is there in unsupervised learning? In unsupervised learning, we are having thousands of images. Now, from that thousand of images, we need to extract how many images of different shapes or of different color are there, right? So we are extracting the features. But color is one such feature, shape is another such feature. So our model is trained such that it is dividing, classifying our data into three different categories. Category 1, 2, 3. That is known as unsupervised learning, means learning according to the extraction of features, according to the similar features is known as unsupervised learning. Clear with this? Next is one such example of unsupervised learning in real life example is identifying the potential customer base for selling, implementing the clustering algorithms. How many types of persons are there, right? And if we include all these persons, how much our particular selling product to identify the customer groups is there. So we need to identify reinforcement learning. What is there in reinforcement learning? Reinforcement learning is advanced version of unsupervised learning. Now in unsupervised learning, that is classifying based on the features, right? In reinforcement learning, one such example is if a child put a finger on the burning candle, it will hurt. Next time it will not repeat, right? So we inputted the data to the model, and based on the selection of algorithm and based on the environment, the state has been selected and been classified and been learned, so that next time it will be learning more new features similar to this star, or this square. So that's known as reinforcement learning. Learning not from any teacher, learning not from or ourselves, learning from the rewards, learning from the implementation, learning from the actions is known as reinforcement learning. Next, we talk about we need to implement the machine learning algorithms. So there are various machine learning algorithms such as supervised, unsupervised, and reinforcement learning. Again, like supervised, we can have classification in so unsupervised because we didn't know any of the labeling. We are not having any of the labeling, so we cluster all these things. So that comes under unsupervised learning and reinforcement learning. So next is these are the applications of machine learning. So what are the such applications? First one is image recognition. So image recognition is one of the most common applications of machine learning that is used to identify objects, persons, places, digital images, etc. and so on. Next is speech recognition. What do you mean by the term speech recognition? So search voice is such speech recognition that is there in Google Assistant, Siri, Cortana, Alexa, right? Traffic prediction. Traffic prediction means real-time location of a vehicle from Google Maps. Average time has taken on past days at the same time. So that comes under traffic predictions. Product recommendation, Amazon and Netflix best suits for this purpose because once you buy one such product, you'll be having similar recommendation for the same thing. Self-driving cars, one of the most exciting applications of machine learning is self-driving cars. Tesla is the most popular car manufacturing company that is working on self-driving cars that is using unsupervised learning to train the car models to detect people and objects while driving. Next, email span. So these are the various applications of machine learning. Next is, what do you mean by the term IoT? That is Internet of Things. Because we need to merge these two, IoT and machine learning. So Internet of Things is a system of interrelated components that is the combination of hardware and software, the mechanical and digital machines, objects, animals, or people that are provided with unique identifiers. Or earlier, they'll be having radio frequency identifiers to transfer data over a network without requiring human to human or human to computer interaction. Yes. So IoT is a concept of connecting any device with an on and off switch to the internet. This includes everything from cell phones, coffee makers, washing machines, and almost anything else you can think of. So what is thing in IoT? So the IoT is a giant network of connected things. Things can be the relationship between people to things, and things to things. A thing can be a person with heart monitor implant, means these are sometimes of sensors that collects the data, and with the help of machine learning we are going to analyze, we are going to predict the data, we are going to classify the data. That is known as IoT and machine learning. So IoT, or Internet of Things, is a sensor network of billions of smart devices that connect people, system, and other applications to collect and share the data. So internet is a connection of both electronics, sensors, by exchanging data with the manufacturer, operator, or other connected devices based on the infrastructure. Next, we talk about why we require machine learning. Now our main focus is why we require IoT. Because organizations in a variety of industries are using IoT to operate more efficiently, better understand customers, to deliver enhanced customer services, improve decision making, and increasing the value of the businesses. So that is why IoT captures the data and analyzes, machine learning analysis and prediction of data is there. So in IoT ecosystem, we'll be having sensors, communication hardware to collect, send, and act on data they require from the internet, and share the sensor data they collect by connecting to a gateway or other devices. Now what are the various benefits by this? That is save time and money, that is integrated the various business models that generate more revenues, monitor their overall business processes, and so on. Next is, now what are the various IoT applications?
இவ்வளவு fast ஆ எடுக்குறாங்க.
So IoT has become a real buzzword lately. The potential of IoT to shape the future and make our life easier, safer, and more productive has led to lot of applications, hardwares, and ecosystem being developed to support this technology. By 2020, the number of smart IoT connected devices will reach 20 billions. So that's why a huge number, and it will just keep on increasing, right? Because of the sensors embedded in the various things, like in smart cities, in agriculture, in environment, in industrial, everywhere sensors collect the data. Empowering this new technologies require a network architecture which requires several years to develop and years and more to develop. With the development of IoT technologies, the need of IoT app development will increase too. And for this, we'll be having like fleet management, goods tracking, smart metering is there, smart grid management is there, parking sensors is there, smoke detector is there, and these all are having apps. And through these apps, we can analyze that it's okay. Either our, if I talk about transport, either our tire is having loose, either
நம்ம வந்து அப்ப பெர்மிஷன் போட்டு வீட்டுக்கு போய் மாவு அரைச்சுக்கிறேன்.
either our tire is having low, less or more smart buildings, smoke detectors, everything is there in IoT based applications. So the smart world of the future using IoT is using everything, is using smart parking, waste management, water leakages, all are there. So if there is water leakage, there is a smart sensor that tells you that it's okay, your water leakage pipe is broken or not working. So that is the smart word of the future, that is using IoT, using sensors, using machine learning, using AI and deeper. Next, so if I talk about IoT product and services, there is helmet concussion sensor. This wireless sensor has an impact that if you get a single jerk, that will be sent to the that will call the police as well, and that will call to your mates as well. That will call to your relatives as well. Smartphone, but it when a helmet hits too hard, so that is one such sensor. Medical alert watch. We are all are having smart watches, right? If we are having mobile phone and we didn't get the mobile phone, we can directly call from the smartwatches and get the mobile phone. So there are various medical alert watches when we are having high BP, or when we are not we are in a sitting position. So these smartwatches alert us to be in a proper position. There are various garden sensors as well that are there in the agriculture, that are being used in the smart farming in order to have precision farming, in order to have agricultural drones, livestock monitoring, and smart greenhouses. So these are the now how big IoT market is. IoT is exploding. It's made of several devices, from chips to machines to wireless technology, from 2 billion objects to 200 billion objects by 2020. So now the thing is how machine learning links with IoT. So machine learning is one of the critical components of artificial intelligence. Everything here is artificially connected with one another, right? Where the algorithms are developed in order to improve the performance, in order to improve the accuracy, in order to improve the evaluation of the software, right? So IoT stands for the Internet of Things. It is used to connect various devices with the internet and pass the data. So if I talk about IoT and if I talk about machine learning in healthcare, so there are various applications, right? Machine learning in healthcare. Earlier they involved with artificial kidney, electrocardiograms. Next they involved with blood analysis by taking the blood samples and so on. Next we are having PET, positron emission tomography. Or if I talk about more precisely, we'll be having fundus image capturing. Now instead of moving to the invasive, we are moving to the non-invasive nature. That is, there is machine learning and IoT. With the help of IoT devices, we can capture the data, and with the help of machine learning, we are analyzing the data without using the invasive nature in healthcare. We are moving from invasive to non-invasive nature. Now, today's technology is interdisciplinary nowadays. Now, if we need to work on artificial organs, if we need to work on medical imaging, we need to combine information technologies, material sciences, biological sciences together in order to work on one such new generation of medical technology. Next, we talk about machine learning. Machine learning is again having two different perspectives. Yes, we talk about we are having three different learning algorithms: supervised, unsupervised, and reinforcement learning. That is a part of virtual branch because we'll be doing it in computers. Now, what is there in the physical branch? Physical branch includes all those things that are related to the IoT. These are related to physical objects. These are related to the Zigbee local area network. These are related to the skin sensor. These are related to the location and navigation sensors, cardiac sensors, stress sensors, ultrasonic sensors, all sensors are there in ML in physical branch. So that's how IoT linked with machine learning. So what are the use cases of machine learning in healthcare department? Earlier, we need to move to the doctor for the same thing. Now also we require doctors, but AI part AI part reduces the stress of doctors by analyzing or or grading or screening of the disease, and then after that, doctor recommend the special medicine for the same. Next, we'll be having role of ML in public healthcare. So ML in disease surveillance, in epidemic prediction. Then after that, screening is there, and after that, role of ML in water treatment is there. So this is a proper procedure. Of course, we need to surveillance of diseases there, like we collect the data from different sources, and then we predict the epidemic, that whether this water is dusty or not, and after that what we can rely on this water or not, and after that will be screen that, and treatment is there accordingly, according to the impurity of the water. So that is there, that is the role of machine learning, starting from surveillance to the treatment. So now what can be the various applications of machine learning with IoT? There are driving. There are the concept of autonomous or self-driving cars has been around for quite some time now. In fact, the first semi-autonomous car was developed by a mechanical engineering laboratory in Japan. Right? Since then, a lot of researchers and development have gone into building such cars. Next is robotic vacuum cleaners. Robotic compactly designed, these robotic vacuum cleaners can navigate their way around your home and vacuum it for you, right? That will be having smart havoc as well. HVAC stands for heating, ventilation, and air conditioner system. Consists of all the appliances that are used to heat, cool, and ventilate the space. A smart thermostat automatically adjusts the temperature of the air conditioner or heater based on the internal conditions. So, with these are the things in which IoT has been amalgamated. IoT has been amalgamated with machine learning to give you a societal benefit to everyone so that you can live with ease. Risk management. IoT and machine learning not just find applications in product development but also in service management. These two technologies can be used in tandem to identify possible causes of system or hardware failure in advance and prevent them. Smart energy management. Another of the sector where IoT and machine learning can be applied is smart energy management. These technologies can be effectively used to optimize the energy consumption, which can be done by smart grids, smart electricity, smart cities. Now, one of the most ambitious futuristic application of the fusion of two technologies is the development of smart cities. Then we'll be having smart lights, smart parking, smart roads in smart cities, smart homes. With the help of Google, with the help of Alexa, we can switch on and off the lights as well. Retail, e-commerce, all these are the applications of machine learning with IoT. So, what can be the various possible challenges of machine learning with IoT? The Internet of Things has been facing many areas like IoT, everything. IoT is everywhere in IT sector, in healthcare sector, in data analytics sector, agriculture, farming, smart cities, everywhere. The IoT sector is. Now, what can be the loopholes or what can be the challenges? Scalability is one such challenge because billions of internet enabled devices get connected in a huge network. Large volumes of data are needed to be processed, and the system that stores, analyzes the data from these IoT devices needs to be scalable, right? Interoperability means data should be gathered from the devices and should be put it to the cloud, and from that that should be applicable to the machine learning algorithms as well. So technological standards in most areas are still fragmented. These technologies need to be converged, which would help us in establishing a common framework and standard for the IoT devices. Lack of government support, government and regulatory bodies like FDA should come up and bring up regulations by setting up a standard committee for safety and security of devices and people. Safety of patients. Most of the IoT devices are left unattended, right? As they are connected with real world objects, if used on patients as wearable devices, any technical error in security can be life threatening for the patient. So these are the various challenges. There are some other challenges as well: data security, privacy, volume, and complexity. Some IoT devices collect highly sensitive data that is there in Internet of Medical Things or Internet of Healthcare Things devices, including protected health information, internet connected cameras, voice assistant, and similar tools to monitor the people activity and conversation. So IoT devices used in manufacturing have access to sensitive data. We need to have the proper privacy protocols in order to secure the data. Volume, so data volume in 2019 IoT devices generated an estimated 18.3 zettabytes of data, which is expected to grow by 73.1 by 2025. And data is because these devices collect as much information as possible and send it to the cloud for processing. In addition to producing massive volumes of data, this approach also creates complex data sets. Now, what is the future of ML with IoT? Future of ML with IoT links with healthcare, links with smart cities, links with security, manufacturing, education, in every sector that can be linked with. Now the conclusion is the current application of machine learning and IoT is just the tip of the iceberg, and there is still more to explore in both the fields. With the constant growth of technology, we can assure it making our lives easier and lead to a better way of innovation. We can truly say automating things around us helps in making our life easier and hopefully safer. These are the references I have used, and thank you. Any queries?
Thank you, ma'am.
Any queries, please?
Please need the PDF for that content.
Okay, I'll surely send it to sir, and sir will send it to you.
Ma'am, what sort of algorithms are used with respect to this machine learning? Can you
Okay, sir.
suggest some?
Sir, uh, okay, sir. If you talk about the machine learning algorithms, so broadly it has been classified into wait. Broadly, it is classified into supervised, unsupervised, and reinforcement. So, if I talk about supervised, if if I give you the images of cat, or if I give you the images of dog, that means I explicitly label them cat or dog. That comes under supervised learning. So, if you are having the data set of labeled data set, so then you'll be able to use the supervised learning. But if you are not having the labeled data set, still you need to implement the machine learning, then you need to move to the unsupervised learning. How? Because based on the feature extracted, because cat is having different features as compared to dog, so based on the features extracted from the computer, that is from based on the features, we'll be going to cluster these features, we'll be going to cluster the images into one, that is known as unsupervised learning. So it purely depends only on you if you are having which data set. If you are having labeled data set, you need to focus on supervised. If you are having unlabeled data set, you need to focus on unsupervised.
Excuse me, ma'am, but with respect to these algorithms, whether it is possible with respect to all sorts of languages, or is there any depicted language to follow this procedure?
No, no, sir. It can be implemented, machine learning can be implemented through Python as well, through Java as well, but it is more efficient. There are various tools as well for nowadays implementing machine learning. There are Baker tool as well. If you need to start your, uh, if you need to start for the implementation purpose, you can use either the Veka or the Rapid Miner tool for the same, only to have the implementation part, right? Only to
Thank you
have the
so much.
result. Yes,
Thank
but
you.
if you need to work on the languages, so there are various languages as well, Java, Python, that can be implemented in any of the language, and there are MATLAB tool as well in order to implement the same. I hope your doubt is clear now, sir.
Yeah. Thank you very much, ma'am. Thank you, ma'am. It's clear,
Okay.
ma'am.
Okay. Anyone else?
Learning what kind of software we can use, ma'am? Only R programming or any other applications are there?
No. If I talk about R programming, in R programming also you need to do the coding part, right? But if you
Okay.
move to the Veka tool or to Rapid Miner tool, you only need to like make the model. Like this is a model, you need to implement KNN. You need not to do any coding part. You only done with the implementation of these parts and only for the results part. If you are working on the results part, if you need to analyze the results part, then it's better to work on the tools. But yes, if you are working on implementation of these algorithms, if you need to work on making the new hybrid algorithms, then you need to work on the languages
Okay,
by
ma'am.
implementing the
Okay.
language.
Thank you, ma'am.
Okay. Anyone else?
I think, yeah.
Anyone else?
Yeah, I'm audible.
Yes, yes.
Ma'am, if I say if I need to start from scratch, for instance, so if you can briefly tell what are the real steps to reach up to the last stage we call as prediction. So for instance, I work on image based prediction. I work on images. So if I say if I want to use this AI or ML, so means what should be the say steps? So
Okay, sir. If I talk about it, I personally also worked on medical image analysis, so I can brief you that as well. First and foremost thing is if you are having data set as well, that is of images that can be publicly available or that can be privately available, both as well, right? That can be gold standard data set as well, and that can be privately available data set. But these data sets are also not refined in a proper manner because image can be having various issues like images having a noise, images having contrast issue, images having intensity issue. So all these issues should be considered first. And the first and foremost thing is we need to identify with the pre-processing, right? So pre-processing of images means we need to analyze the images, we need to clear the images, and there are various filters for the same. Like Wiener filter is there, median filter is there. So there are so many filters. You need to analyze these filters. Next, after that, it's up to you whether you need to move to the deep learning part, AI part, or whether you need to move to the machine learning part.
okay.
Once you have done with the pre-processing, next you can apply any of the algorithms and any of the machine learning or any of the hybrid algorithms, and with the help of deep learning, because today's scenario is any deep learning mixed with machine learning is a new buzz nowadays. So you can mix pre-processing technique with the segmentation. After that, feature extraction, feature can be extracted with any of the model, like auto thresholding model is there, various other models are there. So after feature extraction, classification is there in which whether your disease your image is diseased image or not. That is there in the machine learning or deep learning or AI.
Okay. Okay. Thank you so much, ma'am.
Yeah.
Anybody else? How IoT technology used in image side?
Can you please repeat the same?
How can IoT technology can be used in image side? That means in
Okay.
image.
Okay. See, how IoT linked with machine learning is a good question. Now, IoT is Internet of Things, right? In Internet of Things also will be having various devices such as Raspberry Pi, such as Arduino, right? In that will be having sensor, camera sensor is there, right? With that, we can attach Raspberry Pi. Raspberry Pi is nothing but a small CPU. What the CPU can do, we will be having the small dimensions of this much only, and we can do everything with that particular Raspberry Pi, right? So we'll be attaching one camera with that, and we can take images from anywhere, like from agriculture as well, from everything. And after taking the images, we'll be putting it into the cloud, and after that, AI comes into picture or ML comes into picture. So IoT collects the data in with the help of electronics, with the help of devices, and machine learning analyzes the data or predicts the data or in order to diagnose the severity of the disease. Hello.
Morning.
Anybody?
Hello.
Yes, sir.
Thank you so much.
Yes.
Good morning. It was extremely knowledgeable. Thank you so much. Please, Doctora, do you think using IoTs in learning processes will be able to enhance new knowledge with skills, especially in learning and teaching foreign languages?
Obviously, IoT is embedded. Like if I talk about in today's scenario, we are talking about, you can think of as embedded devices, right? But in today's scenario, we'll be having smart sensors or smart stickers that are skin sensors that can be attached to our skin, and that is also the IoT devices. So with the help of that skin sticker also, we are analyzing the health thing. So with the help of IoT, we are analyzing most of our health devices, most of our agriculture devices, most of our smart cities devices. So everything is being there in the IoT. So now in a few years or by 2025, all things will be transferred into IoT based devices. Now you can see one such example of smartwatch as well. You can see the pacemaker, how many steps you learn, and how where is your phone. You can access the alarm clock, everything with this workouts with this smartwatch. So that is one such example of IoT. So this is a booming technology.
What are the data set we used for image processing?
Yes.
The data set, what and all we can use for image processing?
Okay. If we talk about data sets, right? So there are two types of data set. One is publicly available data set. I can show you now as well. If I talk about, is my screen visible?
Yes, ma'am.
So there are thousands of images available that are having various dimensions as well. Some are of JPG images, some are of PNG images. So one such thing is, you need to, if you are doing any implementation or if you are performing any of the algorithms, You need to work on one similar types of images. That can be the PNG, HEC, that can be of any of the kind of images. That is not a restriction that you need to have only this kind of image only. Anyone else?
Anyone else? Thank you, Dr. Dimple Nagpal, for an enlightening presentation. On behalf of everyone present over here today, thank you for taking the time to speak to us today on the very important topic of applications of ML with IoT. Thank you so much for your valuable insights for our participants, which should be very helpful in this realistic world. Thank you so much, ma'am.
Thank you. And if anyone need to contact, they can contact on my email address as well. Ma'am, where to send the email address? Ma'am will share it to you. I'll forward to her. Thank you so much.
Yes, madam. Thank you very much.